As I have told in the last video that I'm going to discuss about few calculations in single surface refractive interference. So let's just start with the calculation. Let's suppose that there is a glass tube whose one surface has power and another surface is just parallel, and let's take there is a plano surface in back of the glass, and the glass surface has a refractive index of 1.0. So 1.50. So let's take an example. The surface has a curvature of 10 centimeter. Let's take an example of radius of curvature is 10 centimeter. So this is 10 centimeter. So what is the power of this surface? This surface. What is the power of this surface? We can tell that this is 1 index because it's air, and this is 1.5 index. So higher index bulges towards the lower index, which is convex surface. Basically the surface has power of plus power. So if we put this power n dash minus n divided by r, this formula, what is n dash? It's central important concept because we always consider light travel from left to right. So when we are talking about this surface, it's central important to understand n dash means the light travels from one medium and the surface touch and we entering into the another medium. Not here but here. We're entering into the another medium from this surface. So that's another medium is n dash and the previous medium is n. Are you getting the concept? It's such an important concept. I'll talk about this in another example too, but this is a simple example. So n dash is 1.5, as this is glass, n is 1, and divided by our radius of curvature. So radius of curvature we take 10, which means 0.1 meter, isn't it? So 0.5 divided by 0.1 is equal to, what do we have? It's 5 diameter. So this surface has power of 5 diopter in plus. Definitely this is convex surface, so it's simple. So let's take another example. And oh, one good point I have to tell you that when we talk about this surface and the radius of curvature 10 diopter, we consider it's plus 10 diopter because from this surface towards the this radius center of the curvature, the direction from their surface to the center of the radius of curvature is towards the direction of light. That's why we take it as a plus. Let's consider another example. This is this glass slab 1.50 index, and this is the radius of curvature. Let's take example. Another again, radius of curvature is 10 centimeter. But for this case we take example of air. In this case air bulges towards the higher index glass. That's why this surface is concave surface, is negative surface. We can tell easily about it. But let's calculate. The power is equal to n dash minus n divided by r, which means n dash from surface to back, this is 1.5 minus n, the previous surface where light comes. This is the previous surface where is air, which is 1, and the radius of curvature. Now the main important point, the radius of curvature from the surface towards the center of the radius of curvature, which is against the direction of light, isn't it? Which is against the direction of light. That's why we take 0.1 meter as a minus sign. So minus, so altogether 0.50 divided by minus 0.1, which is equal to minus 5 diopter. Power of this surface, power of this surface. So it's centrally important to understand this concept to how surface generate. Okay, this is my favorite example in my class where I had always taught all the students about this concept. So let me discuss. Let's take an example. This is the glass slab, glass ball, and inside of the glass ball there is air trapped. Okay, so let's take an example. From here to here is 20 centimeter. From here, let's do another color from here to inside of it is a 10 centimeter radius of curvature. So glass slab, refractive index 1.0, air trapped 1, and outside of the glass ball it's also air. So this space here trapped air inside of the glass. So it's simple. We have to calculate four surface power. This surface power, this surface power, this surface power, this surface power, isn't it? Or let's make another picture of this and this. This is r is equal to 10 centimeter. In this case this is 20 centimeter. So we have to calculate this surface, this surface, this surface, this surface. Refractive index is 1.5. Isn't it simple? We'll calculate first surface, and that's basically 1.5. So 1.5 minus n, obviously this is air, 1, divided by radius of curvature is 20 centimeter, which means 0.2. So what is the power? The radius of curvature from towards the light of direction from their surface towards the radius of curvature is plus. So simple. So 0.5 to divided by 0.2. What happens there is 5 by 2.5 diameter plus. And this is, let's calculate this. What is happening there? N dash minus s. What is n dash? This is n dash, which is air, and this is n, isn't it? Light coming from there, and it hits the surface and then crosses the air. So that's why n dash is 1 and minus 1.5 diopter divided by r. What is the r? 0.1, isn't it? In this case r is also positive because from surface towards the direction of the light, so it's positive, which means basically minus 0.5 divided by 0.1 is equal to minus 5. So this surface is 2.5 diopter, this surface is minus 5 diopter. At the same time, let's calculate about this surface. It is from air, it bulges towards the 1.5, isn't it? So air bulges toward is negative, isn't it? So 1.5 is n dash minus what happened here is 1 divided by, now it's different. From this surface, r goes from there, which is against the light direction, isn't it? This is the light direction. From this surface, you come to the radius of curvature, which is against the direction of light. That's why 0.1. And eventually 0.5 divided by 0.1 minus, which is basically minus 5 diopter, again minus 5 diopter. In this surface, this is higher index bulges towards the lower index, isn't it? It's about convex. So n dash is equal to, this is n dash, isn't it? Light hits there and the air, this is n dash, and 1 minus 1.50 divided by the radius of curvature, which is again from this surface towards the center, which is against the light direction. So minus 0.2, which is equal to minus 0.50 divided by minus 0.2 is equal to minus 0. Is equal to minus, so plus 2.50, isn't it? So we come to know that the inner two surfaces are minus and outer two surfaces are positive. Why it happens? Because in outer two surfaces, higher index bulges towards the lower index. In inner two surfaces, lower index bulges towards the higher index. So when lower image is bulges towards the higher index, it's called uh, concave surface. But when higher index bulges towards the lower index, it's called convex surface. So it's very important diagram and concept that you have to understand. Another concept that I want to emphasize is how to see the normal in case of how to pull, write or draw normal in case of curved surface. So it's, there is only central concept is whenever you draw the circle from center, every radius is always and always become normal to the pointed perimeter. Every radius, it doesn't matter where it comes from. So every radius is normal to the surface. This is the central concept of optics. So when you are discussing about the single surface refractive interference. Let's take an example. This is the surface and the radius of curvature lies here. So whenever, let's take an example, this is the light coming from infinity and it hits, then how you draw the normal to this point. So in this point you draw the radius of curvature, and this is the normal, and this is normal, and this is the angle, is angle of incidence. So when it refracts, this is angle of deviation. So when you pull radius to the point at the surface, it becomes automatically normal. It's central important concept. This concept is very important when we're discussing about the aberration and all these things, and always important when we're trying to draw about simple lenses or draw about anything. So you have to understand the concept of drawing the normal in curved surface. It's very important because, see, in case of prism, it's very easy to draw the normal, isn't it? That's normal, isn't it? That's normal, isn't it? That's normal. So in case of prism, where a straight line, it's very easy to draw the normal. But in case of circles, it's central important to understand the radius of the circle is always, it's is always perpendicular. Radius of the circle is always normal. Radius of the circle is always normal at the periphery, at the point of that circle periphery. So you have to understand this concept, and you have to understand the few calculations. And let me tell you the mistakes many of the students make. First, they make mistakes to put values where n dash and where n is. Let me tell you one more time. N dash is always, let's consider light travel from left to the right. N dash is always after the surface. This is n dash after the surface. N is always before the surface. So it's central important to understand. N dash is always after the surface. Light hits the surface and then move inside. That after the surface is always n dash. And in case of radius of curvature, student make a lot of mistake. If radius of curvature, let's take an example of, in this case, a radius of curvature from surface towards the center of the radius of curvature, then it's in the direction of light, it's positive. But in case of this, radius of curvature, center of the radius of curvature there, and from lens, from surface towards this direction, which is against the direction of light, is negative. So you have to understand where you have to take positive and where you have to take negative. So many of the students make mistake in this case. So this is a great example that I have already told you. If there is four surfaces and this air, this is 1.5 index. See, for this surface, n dash is this. 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 Are you getting the concept? Okay. For this surface, radius of curvature in the direction of light, because surface towards the, for this surface, radius of curvature in the direction of light. But for this surface, radius of curvature is against the direction of light. For this surface, because we have to take from surface to the center. For this surface, against the direction of light. That's why here r is negative, here r is negative, here r is positive, here r is positive. You have to understand this concept so that the later on you will not make mistakes. So for today it's already 14 minutes. So for today I'm going to stop there, and I think I will go to talk about thin lenses and all other things. But as we progress in these videos, we will make small comments and concepts where you basically get fail to recognize that concept and fail in exam and fail in basic concept along your life, so that you understand a lot of things. We will definitely talk about single surface refractive interference when we talk about scleral lens, when we talk about intraocular lens, when we talk about cornea, when we talk about the optics of eye. So in every chapter it comes again and again, so it's central important. Please tell me if you want any other videos, any other concepts of optics, a small concept, it doesn't matter. I'll try to make time and make one video. So Thank you so much for the today.